everyone, and welcome to the last day of CloudStack Collaboration Conference. We're here with Apache Ranjan, who was our keynote speaker at the first day, and today he will tell us a little bit more about the technical side of how they're using CloudStack in CSC. Hi, Abhishek.
Hi, Yvette.
Welcome again, and the stage is yours.
Thank you so much. So, hello, everyone. Thank you again for joining me on the session today. And today we're going to talk about how we are using CloudStack to deliver citizen services. So, and I think that we have a lot of audience from across the world. So we would be very happy to share the experience that we have with CloudStack. And we'll also love to share what we're doing and what are the new initiatives we're taking up at CSC in terms of using or building a compute offering. So, so before I'm sure that I had a last on the 9th of November, I had the first session where we talked about what CSC does and how what we're doing. However, just for many people who have not, who might have missed that particular session and have joined today, just to give an idea and overview what CSC is. So this slide is about what CSC is and what we do. So CSC is a special purpose vehicle which is set up by the Ministry of Electronics and IT. It was set up as a project in 2006 and to bring in more autonomy. And the idea was to have a network of kiosks all across the country from where the government services could ideally be delivered to the citizens without letting the citizens walk to the nearest government office, thereby bringing a lot of convenience for the people around and making it more easier and rolling the way out for electronic governance. However, to bring in more autonomy, the entire project was given an autonomous, formed into an autonomous body, which was termed as CSC E-Governance Services and incorporated as a public sector unit organization, though limited by shares. So we started off with the project version 1 in 2006, where we had approximately the mandate of having like 1,100,000 kiosks all across the country. And in the year, while I joined back the CSC network in the year 2015, and since then the mandate was again the recursion version, the CSC 2.0, where it was decided that we bring up the network to a number of 2.5 lakhs, approximately covering all of the lower segment of the governance body in the country, which is the Gram Panchayats, we call it, or the county offices, as you may compare it to any foreign nation. So to cover all of them, so as of date, today we are operating with almost like a network of 4,467,000 IT enabled front-end service points for delivering both government and business services across the country. And this by far, I hope, and I think that it's one of the largest network of its format to bring in the front-end service delivery. So we are a team of approximately 600 people across the country, and out of which we have a dedicated team of like 100 plus IT professionals who work with me directly and for the building up the various applications and services that we run as a product and a service, as well as the infrastructure which we run and which is actually built on CloudStack for offering us services to the users. So in a nutshell, CSC is present as an omni-channel service delivery framework in a network, which encompasses various segments, and it covers almost all of the domains as we may talk, like agriculture, health, education, finance, fintech, financial services like insurance, banking, and even we are rolling out telecom services, as well as bringing about the government services all across. That is one of the key areas that we are also present as. So out of it's pretty important that I share and express to you the network or the portfolio of services that we run at CSC, which brings as a core platform of the applications that we use to offer or deliver services. And largely they are delivered and bifurcated into multiple applications. So this I'll just categorize to a very high level. However, we may have a number of independent other services, which could be a subsidiary application, you can say, or a supportive application channel to support a service delivery framework. So the whole CSC system starts off with registration application, which is the starting point for any individual to become the part of the CSC network. That's the CSC registration system. We have a CSC Connect. That's another application. It's an OAuth-based authentication platform, which we use to connect and integrate with partner channels, wherein we could give a seamless experience of a single sign-on and application delivery to multiple all the CSC users, and they could easily access the government services with one single user ID and a framework. And then again, the flagship portal that we have, which is the digital portal, which is a curation of all these services bringing together, wherein we have approximately like some 25,000 services if we cater them to one single list. However, if we categorize them to categories of business verticals, then it would be somewhere like 14 and 15 services. Similarly, we also have a digital wallet, which is used for making digital payments for the services being availed on the system, and then and making for payments, and there is a channel for connecting their wallets to the bank account for loading cash and as well. And likewise, we have a profile services so that we can explore and extend the CSC user across the system. And then we have an application called DigiPay, which is a financial banking application, which is used for bringing in banking services to the unbanked area. And it's built completely on the digital ID platform, which is called Aadhaar in India. And we use the same for doing banking application transactions like basic cash withdrawal, deposit, you can, as well as balance inquiry, etc. Similarly, there's another system which is entity or regulated body by the Reserve Bank, Central Bank in India, which operates a platform called the Bharat Bill Payment, which is a unified payments platform for billers and services all across the country. So it brings upon another lead of a single unified channel for making multiple bill services and payments for catering to the individual users across the country. Then apart from many of the financial transaction services that we have, we also have a lot of business transaction applications, so which are used for identity authentication or for KYC service delivery, wherein the authentication service or the AUAS, we call it the Aadhaar authentication platform here at CSC, which is a platform which is used for authenticating anybody using the Aadhaar authentication system, which is based on your the Aadhaar number, which is the digital ID number issued in India. And you can authenticate yourself against various modalities like a demographic authentication or a mobile-based OTP or your fingerprint or your iris or even a face. So all this can be achieved from anywhere, anytime. It's all API-based authentication system. However, it's a very different channel of like originating from the client and routing to the authorities' central information data repository. So we also run one of the largest ASAs in the country. And then again, we have email services for all our internal users, as well as the we call the entrepreneur network that works with us. And at the last one of our key application platforms again is we are also like offering digital certificate from our stable, which is electronic digital certificate, which is a certifying authority in an actual system. But however, it works in a very different way as compared to the other certificates that you do. So for any certificate that you buy, you have to get you have to do a KYC, and you get a digital certificate either on a dongle, or if it's a class 3, it is routed to your HSM and on. Similarly, in the e-sign, it's a one-time usage digital certificate, which is issued instantly based on your electronic KYC, which is done again using your Aadhaar authentication numbers. So this is all about the core platforms that we have at CSC. And however, coming on to all these things brought together, I just did a transaction analysis to say like what kind of load or volume that we are managing at our setup at present. So I have taken the stats for the daily transaction based on yesterday's transaction that we performed, and the monthly and yearly is based on the last 12 months scenario what we have done altogether. So as I said that we our prime application portfolios. So we talk about the digital portal and the DigiPay, which are the financial transactions in the system, and the rest of them like the Aadhaar authentication, Bharat Bill Pay, the Ayushman Bharat, the insurance registration program. And we also had a COVID registration stint wherein we facilitated the registration of people in the rural areas for getting vaccinated for the COVID-19 virus. So, and then again, as I said, that we have for the other portfolio applications brought together. So on a daily, we do approximately like 5.4 million. That is what we did yesterday. However, the transaction was split between like 1.3 million into the financials, and the rest were all business transactions. Likewise, approximately we do approximately like an average of 80 million, 79 million here. So of transactions in a month, and then approximately 948 billion altogether, covering all the transactions, including the business and financial, over the last 12 months that we've done. So this is what in terms of the application portfolio and the services, as well as the utilization and operations that we're doing every day on a daily day-to-day basis, is what is being all of these are actually I've taken for all the applications that we're running on the CloudStack platform that we operate. So now on the infrastructure distribution, I would just bifurcate like how we are set up into the entire our infrastructure offering. So we operate from 3 different locations, which is our prime data centers. So almost all of them are tier 4 and tier 3 certified. So at the primary site, we have a CloudStack setup, which we call it the DC1, and the DC2 also we have a CloudStack setup. And for both of them, we have a separate management, a separate cloud console. And however, the infrastructure is almost all of the same size, and we built in a completely HA mode, so that there was no single point of failure in the infrastructure that we built. Thirdly, then we have a third site, which is the DC, which is again a tier 4, from where we also operate our digital certifying authority services, as well as we are also building up a cloud, our entire infrastructure is dark site for data replication and safety relocation and all. And however, the fourth side, which is our business office, from where we operate the NOC, the SOC, and we have a development platform, as well as we do all the application monitoring and sustainability from the same location. Coming to my CloudStack deployment, I think this is going to be something which is going to interest to you, all of you. Like it may not be a very large setup, but however, we have tried to suit it to our taste and our requirements. So basically, the first of all, so it would be one of the questions that many people have, that why don't we use and we go on to a public cloud like Amazon or Azure, and why did we choose to even think of building something at our own end, where it takes a lot of burden on maintaining the infrastructure, maintaining the data center services, and again monitoring, and all those threats again, which are again offloaded to your head, that we have to balance it out. However, since, as I said, that we do a lot of applications which requires a lot of high level of governance and a statutory compliant requirement. So that was one of the prime reasons that we had to do this. And then again, there are a lot of things which were actually not possible to like operate from a cloud environment in a public cloud environment. So we had to think something that we will have to build something at our end. And however, while building, so as I said in the last talk as well, that when we started building this entire infrastructure in 2015, so that point of time, which was our planning phase, and we started executing the same in 2016. So during the time when we started buying the servers and the network equipments and firewalls and other devices, that point in time we were actually very worried about, because we had limited space, and approximately now I have approximately 400 or 500, 600, on an average 600 square feet of data co-location space at all the facility. However, when we started building, we had a constraint on like how do we go about and use all the servers, because we had a very the application portfolio at our end was very large, and the offerings was also very large, and the audience that we were going to cater was always supposed to grow, and we had limited room to think that how we could sustain the entire thing within the same setup, and without having to go in and buy more and more servers, and at the same time being compliant to all the requirements that we had in the world. So that is where we started choosing for an option of building and setting up a cloud, private cloud setup at our own end, and that is where we started exploring out. And however, that is where we came in, we explored and we found out CloudStack, and we started experimenting out with the CloudStack. The first installation we did, it was on a single server, and we tried. However, understanding the usability and the simplicity of the CloudStack application system, it gave us a go ahead that, yeah, this is the thing that you're looking for, and this is what you should be actually using to build your cloud. Because it was so simple, and we just loved the thing, yum install CloudStack management. It makes it so easy to install and run and maintain. And over the last 5 years, I would say that it has been a very, very seamless journey for us. Though we had our own share of failures at times and outages, however, we learned from what we've been doing, and it has actually helped us evolve. And the overall journey of building the CloudStack system in the last 5 years, we have seen that we love the documentation, that the official documentation was there, and the only other resource we could find was at ShapeDo. So we also like ShapeDo a lot. We love the blogs and we read them a lot. And we have a very small team which builds and operates. There were 4 or 5 people, all of us, we joined together to set up all this infrastructure that we run today. And today we have like 18 people infra team, which manages all the operations, including the application support, hosting, maintenance, and the network operation center and the security operations center. That is how we manned up. And most of the things we have done is like we try to automate as much as possible. We have built our own RPAs at the back end to ensure that our system works properly. However, coming back to the CloudStack setup, since our requirements was that we had to have a large-scale applications portfolio, which would require a lot of, because as I say that there are applications which requires that we also, for the financial transactions that we do, or even the business transactions that we are doing. So almost all of them require statutory compliances, which require that we store the data locally. That is, we store the data in India. And secondly, that we also retain the data logs and the audit trails are the same for a period of 7 years or 10 years as per the case. And in the case of financial transactions, we don't even bother to delete them. We store it permanently. However, to bring in all, so we had to design something where we could actually have the scale of a cloud operations at the same time. We do also have backup. And then we also had the problem of getting all the threats and security concerns. So we had to build something which was totally segregated. So we never use any virtual devices for our security UTMs and the load balancer level also. We thought that the hardware load balancer would suffice. So that is how we built up. So if you see that in the diagram which I display here, it talks about how we have set up the cloud infrastructure at our end. So you can see that we have a compute block which says that we added a lot of servers there, which is a mix of rack and blade and all high-end servers. Probably we have all of them as HP, and then I think all of them are HP, and almost 58 host machines are there across the 3 locations. The third site is all physical. So just talk about the 2 where we run the CloudStack, that the DC1 and DC2. So we have almost like 58 host machines with an average of almost like 48 to 64 core per servers. That is the processor side. And we have built it on a 10 Gbps network fiber. And that is on a bridge, which is on a round robin. So in case one of the switches fail, it's still the cloud doesn't go off. And almost all the host machines that we run open KVM there. And almost every application software that we have built here or we are running is totally unlicensed except for the antivirus. So that is only the software that we have today as a licensed software here. On the storage side, when we started building the cloud, so we only had an NFS stack in the primary and the secondary storage here. But later on, when we started adding the SSD servers there, then we started building on a Ceph node, and we attached Ceph, and we use Ceph as one of the storage services there. However, we have been trying to work on a managed storage, which is a Nimble-based device that we have today. So, and we're trying to build it as like an enterprise managed storage to be available on the cloud directly. However, we have not been able to do so, but we have been trying to work on an alternative to that. And that again, so that is how the setup is there. And on the network side, so we have the computes on a round robin, and the storage works on either a round robin or a fiber channel as maybe the devices. And then we run almost all the application servers into the different zones. based on the guest network, and we have a web zone, we have a data storage zone, and we have a physical management zone where we run the CloudStack management, which is not accessible to on a public network. It is, I mean, you need to connect to my data center, or you have to be available in the SOC or the NOC so that you can access the management CloudStack management service. And that is where we also run. I'll go detail in the next slide. However, almost all the traffic between the guest network is always routed and segregated on VLANs through the firewalls. That is how we've built up here. So going to the next slide, which is the architecture of one of my setups, which actually says how we've built up the entire thing. So we have uplink connectivity, and then we have the routers there, then the firewalls, and almost all the both the sites, both the data centers, we are completely available on HA, and the switches and the load balancer all are physical. And then we have the management zone. We have the physical servers. There's again complete pool of compute servers and a complete pool of storage servers, which is the physical server zones. And then we have a backup and storage. We have multiple backup devices here. So comprising of the disk to disk, D2D storage devices, as well as the disk to tape, which are those robotic arms and the tape storage. And then we have the management zone where we run the LDAP, which is again the open LDAP, and then the Active Directory also there for a lot of other Windows services and all. And then we have the endpoint protection for the antivirus. We have a monitoring stack there, which is actually on PRTG. Again, that is one of the other licenses that we have. And then we have a Elastic Search, ELK stack, and Kibana-based monitoring system that we have built here. And then we have a Splunk-based SIEM tool and a syslog server for the logs, audit logs, trailing and retaining all the logs here. So that some of them are actually built on virtual machines, and some of them run on a physical machine. So it's like bifurcated like that there. However, on the application side, as you can see my diagram here, it says that I have an MPLS pool here, so which helps me connect to my remote location. That means that the DC1 and DC2 are actually not connected over the internet, but we have a dedicated MPLS P2, you can say a P2P link, which helps us get connected to both the sites, and which we use for data replication and for data routing internally for the safety of the data that we are running in our end. And then again, we have MPLS connectivity to the financial switches as well as the CIDRs for performing the financial transactions and the business authentication services. We can see the zones, and we have the data store zones, and we also have a secure zone. If there's some application which does not require any public exposure but still has to be run there as an application, we do not expose it over the internet, and we keep it as a protected behind the firewalls line, and that is again the secure one. So this is how we are overall like set up into the entire application platform that we run today. And then on the we have a pool of other stuff that we keep doing for, like as I said, that for the dev operations, we do have Elastic Stack and Kibana for log monitoring and log stash as well. We have a small implementation of log stash for the log analysis and that. And then we have the PRTG for the infrastructure management monitoring and all. And we also use Ansible for the automation part, and Ceph is as well Ceph for the storage as a primary storage node here. However, we have been working on an implementation where we are trying to build a Ceph-based S3-like object storage network, which we intend to build a 400 terabytes of object storage that suits our need, and it would be something like a bucket, and those functions are available on the Ceph code, and we are almost like on the testing site right now, and probably another week or two, so we would be live with the same. So these are on the development operations that we're doing. As for the certification and standards for my setup that we run here, we are a completely 27001 certified, and we have been certified since 2018. And again, we certified for 20,000 for the configuration, the service management, 20,000 for the systems and the application portfolios that we have. And our infrastructure is completely CISA, DISA certified. That is a basic requirement to get payment system certifications. And our setup is also certified for the payment systems. And we are also a certifying authority. So we also comply with the IT Act which is again an extension and deep-rooted detail of the 27001 framework. However, that is an act in the country, and we adhere to it completely and we comply so that we can operate as a certification authority as well. I mean, a certifying authority. And we are also undergoing a PCI DSS, which is one of the new initiatives. We are really very, very recent initiative that we have taken up, as we are going for a number of further licenses. We intend to do card and processing. So probably that is a requirement that you need to get a PCI DSS, and we are going further for a PCI DSS certification as well. And I think this is all we have. And the application, I thought that the infrastructure does perform a lot. It's very important that the infrastructure perform, but however, it's equally important that how we design our applications. So most of the applications are again open source software platforms, and we use Node, PHP, Vue.js, Java for most of our application offerings here. And for the data stores, we use MySQL community again, and almost we run a mix and match of 5.7 MySQL and the latest 8 MySQL 8. And we use a lot of Redis here for the caching and even for key value data stores for a lot of instances as well. And most of the servers that we run is primarily Nginx or a Tomcat or custom node-based servers. However, and further, most of the servers that we run we have operating systems. Basically, almost all of them we are running on CentOS, and that is ranging from 7.6 to the 7.9 version of CentOS, and then we have a limited number of Windows servers as well. So this is what I all have for the day, and probably I would say that we can go back to the question session, and if there's something you would like to know from us, we would be very happy to share with you, as well as we would also be very keen to learn from the network. And there are a few things that we want to say, that we love CloudStack, and there are a few things that's very important we really appreciate about CloudStack is that is just simple as yum install. That is the most beautiful part that one could have. The other is the documentation is really awesome at the CloudStack official documentation site, as well as the shapebook blogs are very helpful. And I've seen so many guest blogs there when talking about Ceph and other stuff. They're very, very interesting reads, and we really appreciate. They help us a lot of with a lot of the learning that we have taken up, and it's a very small initiative here. However, we have been learning thoroughly with the documents or the videos that you have for the build-up of the infrastructure that we are running today. And above all, the simplicity of CloudStack. As I said, it really helps us. We run the entire operations with we build the entire thing with just 2-3 people, and we run with a very minimum number of people maintaining, so that we can actually focus on our core business operations rather than just worrying about the infrastructure as all. So thank you thank you all for having this patience to listen me out. And I really thank the Apache Software Foundation for having me on the CloudStack Collaboration Conference. Giles and Yvette, thanks a lot for having me here. So I'll just stop my slide, and we can just go back to any questions that you have. I would definitely love to share my experiences there.
Thank you very much, Abhishek. It was really interesting to understand a little bit more for the technical side of your CloudStack implementation. I'm going now to the questions. So I think you answered to this, but Damien is asking about how many people do you have to manage all of the infrastructure? And maybe you can share with us also some insights. Was it hard for you to implement initially CloudStack? And how do you see the project from your perspective?
Probably I can also access the questions, right? Go on the chat.
Yeah, if you walk into the event platform, then you can see the questions, but for your convenience, I can read them.
Yeah, I think I'm not able to find them. Anyways, I'll just go and answer the question that you have. So the first question comes from Dawn, right? Daniel. So hi, Daniel. This is Abhishek. Yeah, you were right. We had a lot of trouble when we started implementing CloudStack, and the first day, we tried it in our office on a single server. We thought that, oh, it's such easy stuff, we can just do it like this. And then we planned everything up that this is the cloud we are going to install. And we went up, we bought all the hardware, we planned up the stuff. We designed our architecture, we designed our infrastructure, and then we went down to the DC location for the initial setup. And that is where the real pain started. We took almost like 120 iterations to get the right installation the first day. So it like took us like something like 72 hours approximately, near around 2 to 3 days to get the right installation, and we did it non-stop. We had complete setup, and we again formatted, and we again installed. So all these iterations, we did a complete like more than 100 rounds of reinstallations to get the right one which is working today with us. And we started off with the version 4.7, 4.6, and today we run the 4.15, and probably we can upgrade to 4.16 as it is available.
Thank you. Going to next question, which is coming from Rohit Yadav. You mentioned something about migrating to enterprise managed storage. Can you expand on that problem and how the CloudStack community can help?
Okay, so we had a short discussion earlier as well on this one. So thank you, Rohit, for the question. So on the managed storage, we have a problem here. Like we bought the devices, which is a HP Nimble device, which is a managed storage, and it's got all flash storage. And however, we see that you have store pools and the other devices like Hitachi, as well as I think I've also seen Dell to be a managed service for available on the primary storage. However, the drivers that we get from the HP Nimble are not being supported by the CloudStack platform. So probably we thought of doing it, but then again, we are not the cloud developers, so we never took the risk of doing such. So we decided that we go the safe way and we use it like that. So that is how we used up. However, we have been trying on that since a long time now, but I think the drivers are not available in the Java framework. So probably that might not be compatible. But yeah, of course, we would certainly love to explore, because these guys have the native integration with the OpenStack platform, and they do have something in the SDKs in Python. So probably if we can do some kind of engineering here and get the Python stack to work on CloudStack, that would be really amazing, and we could just do much more than what we are capable of today.
And was it hard to convince your government to go in this way compared to just buying a turnkey solution? Was it hard to make them choose an open source software?
It was primarily my decision.
So it wasn't hard for sure.
It was not. It was very hard because, as I said, that see the government. We are autonomous body today, and we have a completely we are a limited organizations by shares, and we can actually consider us as a public sector unit. However, we have our own board, but the board doesn't, and then we have a full-time chief executive officer, and I work as the CTO here. So I had the full free hands to decide and do whatever I want to. But then it becomes very tough, because if you're trying to do something for the first time and you really can't afford to fail. So that was one of the pressures that we had. But however, I think as we took the risk. It might be a risk that day, but I think it has paid off so well that people really appreciate. And I go to so many forums and we meet so many people around. And even the AWS guys, we have some sort of a collaboration with AWS also. And we have few platforms that we run in the CSC, which also runs and operates on the AWS. And the AWS guys also are very amazed on the infrastructure kind of setup that we do here. And the compliances we meet on the CloudStack, and at the same time, we have all the flexibility of a cloud system. So that's something really, we are very, very proud of what we do. But yeah, it's really, I again go back and kudos a big shout out for everybody at Shade Blue and the CloudStack Foundation, people for bringing such a wonderful platform in the open source community.
Is the usage of open source solutions some kind of stopper when you need to achieve certification and compliance?
I don't think so, because probably for the certification and compliance, what you need is you need to have a thorough policy for the patch management. You need to have information security standards, and they're very, very standardized these days. So probably somebody would talk about like the vulnerabilities patching should be there in time. You should have a thorough password policy, protection, log rotation, access control management, and a lot of other things. So probably you can definitely build those on top of it. And as far as the applications are concerned, they are again the same thing. If you're running a Java application, probably if that is getting vulnerable, you need to patch it up. You just can't afford whether you run on a commercial platform or you run on an open source. They are both either the same. So you need to patch them. And if the patches are available, you have to do it. And I think the open source community is very vibrant and the patches are available in time. However, in case if they are not, then you really need to work down, and that the open source community gives you this flexibility that you can tweak down the code and build your own stuff. So if you're not getting the support from outside, you can definitely do that inside and you can patch that stuff. But however, I feel that the support is thoroughly available all across.
Thank you, Abhishek. One more question. How are you handling scaling the infrastructure, especially when there is a sudden need for CoWIN platform?
No, so CoWIN platform, we don't run the CoWIN platform. The CoWIN platform is run by a different team and a different organization and department here. However, the CoWIN platform, as I was also part of that team which was building that CoWIN platform during the month of January and February. So we were doing, and that time it was decided and thought process was built in that the CoWIN platform would expose open APIs, and so that people can build applications around it for the registrations and facilitate people to register and schedule for the vaccination. However, since as a community, CSC also has a social cause and we are omnipresent across the rural locations in the country. So advocacy was very important to like bring in the information to the people so that they can also get vaccinated. So that is where we tried to do something so that we could evangelize on this and also boost the morale of the VLEs. I mean, give them some numbers. I mean, if you show them that one person is doing this many numbers of people registration and all, it gives them some sort of a high so that they become more participative. So that was the reason we brought down and we built a CoWIN registration application on the set of APIs. However, we just had an application stack which would open a form and connect to the APIs. But yeah, that also we managed and we did some 3 million registrations in a couple of months. So it was all about mobilizing the people and getting them registered so that they could avail the vaccination.
Thank you. Thank you. That's really impressive. And the social impact is something which worth to mention. I don't think we have more questions. Maybe just one comment from Sunando, our friend from Indicus. Awesome talk. This truly represents the simplicity of CloudStack, and kudos to Abhishek and his team for the success. Thank you so much. Thank you again. I thank you all the people who watched this session. I am really grateful for having the Apache Software Foundation for having me on the platform, as well as the CloudStack team for bringing in such a wonderful platform. Thank you. Thanks, Abhishek, and we're really looking forward to meet you at next events with new updates and more success stories. Have a nice day. Bye. Bye. Thank you.